Hi guys, and welcome to this video. In this video we'll explore nonlinear graphs. So a nonlinear graph has curvy parts or curved parts, and unlike a straight line where you only have 3 coordinates, you'll need to plot more than 3 coordinates to have an accurate sketch. Now, examples of nonlinear equations could be as follows. So this one has a power of 2 in the index. This one we're dividing by x, and this one has a power of x. So this is very different to our y equals mx plus b, which is a straight line, and we have powers of 1 here. Over here we have a power of 2, dividing by x, a power of x. So it's a little bit different in the way the equations look like. Okay, let's have a look at a parabola. A parabola is a type of nonlinear graph. Here is our most basic parabola. It's a curvy graph and it's symmetrical on either side. This equation is y equals x squared. So for every x value, to get our y value, we square it. So if x equals 1, so if we go across to 1, we go up 1 squared. If we go across 2, we go up to 2 squared, which is 4. Across 3, we go up to 3 squared, which is 9. So if we did draw a table of values, we could plot many, many different points, and this is the shape that a parabola follows. So a parabola has a power of 2 with the x, so the x value has a power of 2, and the y has a power of 1 for the parabola. Just a bit of theory on this. A concave up parabola looks like a smiley face, and a concave down parabola, you can kind of guess what that's going to look like. It's going to be a concave down one, which is a frown. Okay, so concave up means that it's, pointing up, and concave down means it's pointing down. You could actually find out if it's concave up or concave down from the equation. So if the equation of the straight line has a positive number in front of the x squared, so the coefficient of x squared is positive, this is what we end up getting. And if I had something like y equals negative x squared, excuse me, you could get something like the concave down parabola. So that's one type of nonlinear graphs. Okay, now an exponential graph looks like this. This is a particular type of exponential. The equation is y equals 2 to the power of x. So for every value of x, we put into the power, we do 2 to the power of that, and we get our y value. For example, if x equals 1, y equals 2 to the power of 1, which is 2. So when x equals 1, we go up to 2. So there's our first point. If x equals 2, y equals 2 to the power of 2. So across 2, up to 4. If x equals 3, y equals 2 to the power of 3, which is a little bit higher than our scale lets us look at. So that would be 2 times 2 times 2, which is 8. If you go on the negative side, if x equals negative 1, y equals 2 to the power of negative 1, and when we did index laws, we know that's 1 over 2 to the power of 1, which is just a half. So there, and then you go up to a half, which is halfway between 0 and 1. If x equals negative 2, so when x equals negative 2, y equals 2 to the power of negative 2, you could do that on your calculator and you'll end up getting 1/4. And then you'll see that it goes down and down and down as we go further negative with our x values. So these types of equations have an x in the power, and it has a different looking shape than our parabola. This one actually approaches 0 over here. So if I just draw a dotted line, that blue line approaches 0, but it never touches 0. So we call this an asymptote. So that dotted line that I drew, which is on the x-axis, that is an asymptote to our exponential function or exponential graph because it approaches it, but it never actually gets there. It looks like it touches it here. However, if I zoom in, you'll see that it doesn't in fact touch it. So that's called an asymptote. There's a new word. Okay, with an example, copy the table of values and then sketch the parabola. So pause the video and have a go at answering this, and we'll see how close you get for the parabola. Okay, so if you substitute -3 into your equation, you'll end up getting y equals -3 squared, then you take away 2, which is equal to +9, take away 2, which is equal to 7. And that's why we've got 7 there. So going across to 3, so -3, and up 7 units, there's our first point. The next one is -2, all squared, then you take away 2, so then we have 4, take away 2, which works out to be 2. So you go across 2 and then up 2. Do the same thing with the -1 and you end up getting -1. 0 is -2, then we have -1, then we have 2, and then we have 7. Now, we don't use a line or a ruler to draw straight lines between the points. It's not like a join the dot to dots. It's drawing a smooth, continuous graph like we saw earlier with the parabola. It goes through all those coordinates. Label it, so y equals x squared, take away 2, and make sure you have arrows on either end of your parabola. So this has a few features. It has a y-intercept. It only has one y-intercept, but it has two x-intercepts. So that's something a little bit new for us. So we've got two x-intercepts and one y-intercept. We don't have to work them out. We only had to sketch the parabola. So just make sure that you don't use a ruler for these, and as accurate as possible, draw your parabola. Okay, thank you for watching this video.